for n behaviors, you got to show all the intercepts. So it's going to include the x and the y intercepts. Okay. So this is going to be a review of something we've talked about in the past. Okay. So your n behaviors. I don't know what it shows on your paper. I might have slid this over or not. But if you've got an even function and you have a positive or a negative coefficient that's leading, what would it look like here? Okay, you're gonna guess. You're gonna go like this. 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 So I'm gonna let you think about it. You can look at your neighbors. You can cheat. I don't care. Even, positive leading coefficient. Go. Cheat off of those guys. That's exactly what it is. So write that there. Even, negative leading coefficient. Go. Good. Odd, positive leading coefficient. Go. Good. And so then, I'll let you write. Odd, negative leading coefficient. There you go. Okay? So that's your n behaviors. So you got to have the proper n behaviors. How about this? What if we have a function that is factored? So let's say that we had something factored like this, and you got this factor to a power, and you got this factor to a power. You should know what happens at an x-intercept of 2. And you should know what happens at an x-intercept of 3. What happens when that power is odd like this? What does it do? It crosses. And here, when it's even, we use that word tangent, that it touches and goes. It touches, does not cross, it just touches at that one location and then bounces back up or bounces back down. Okay? So if you know that, you're going to be able to pretty much graph everything we have. Now, I'm going to put at the top probably the biggest thing, well, not this one yet. That's on another page that you got to do something. Let's see what we got here. Well, let's start with the x-intercepts. That's something we know. So the x-intercept would be a value of x that would make this would be a solution of the equation. Something that when you plug it in would make this expression equal to 0, which in this case would be 2, negative 4, negative 1. Those are your x-intercepts. What's another name for those things? Your zeros of your function, right? Or the solutions of your equation. Multiplicity is just the power. 2, 3, 1. So the multiplicity is this k value. That's all it is. So when that k value is odd, then you know it crosses at that x-intercept. When that k value, that multiplicity is even, it's tangent. Okay? Now, remember that when you talk about the degree of a function, if you have it written in standard form, like this maybe, can you tell the degree by looking at it? Absolutely. What's the degree of this? 4. But see, we don't have that here because we don't have it all multiplied out. So I'm going to show you how to think about it, and then I'm going to show you a shortcut. Okay? So like if you had to multiply this all out, I'm going to ignore all of the numbers that are not variables or powers. So like this would be x squared. This would be x cubed. Again, I'm ignoring the 4 and the negative 2 and the negative 2. What would you get if you multiplied that all out? x to the 6. So your degree is 6, right? Well, here's an easy way of doing it. Look at this. Just add your multiplicities up. Okay? So when you are not in standard form, add your multiplicities up. If it's in standard form, just look at the highest exponent, right? Okay? Don't do this. Don't add those up. Your degree of this is 4. Don't add the 4 and the 3 and the 2. The only time you add the multiplicities up is if you don't know what that leading term is. What would the leading term be if you multiply this all together? I'm telling you it's x to the 6th, so the degree is 6. Okay? Okay, tell me one coordinate of the y-intercept. And which one? The x-coordinate you should know is, what would be this coordinate of this point? Wouldn't it be over nothing? It would have an x value of nothing, and it would have a y value of something, right? So every y-intercept has an x value of 0. So if you were to find the y-intercept now, you plug a 0 in there and you work it out, that's your y-intercept. So y equals -2 times, what do you get if you put a 0 in there? -2 squared times 4, because again we're plugging in 0, right? 4 cubed times 1. Now this is going to be a big number. It ends up being -512. And you're probably like, well, I can't graph that. Sure you can. Is there any scale on here? No? So then put -512 wherever you want. Is that y-intercept necessarily a relative maximum or relative minimum? No, it's just crossing there. So it might cross like this. I would actually like it if you, when you graph this, that you don't make it like the top or the bottom of your curve. Okay, because it doesn't mean that it's a maximum or minimum. It just kind of goes through there. Okay, so that's one thing we got. What else do we got to label? We got to graph our x-intercepts. So I'm going to go to 2, and here's my trick. What happens at that point? It's tangent. So put a t there so that when you do graph it, you do it right. Okay? -4. What happens there? It crosses, so I'm going to put a c there. And -1, it crosses there. Everybody understand why it crosses or why it doesn't cross? Okay, end behaviors. It's an even with a leading coefficient that is negative. Robot. You told me, right? So you got your end behavior here. So I'm going to put my end behaviors, and now all I'm going to do is I'm going to go from left to right and connect the arrow to the other arrow. So what I do here, I go through it. How high? I don't care. Doesn't matter. There's no scale. And then back down through here. Again, down through here. And then how do I go here and end up there? Well, I'm going to bounce off of that. You're done. Okay. And again, I wanted to really go through this and go maybe even a little further down. I didn't want to have you think that that was a minimum. Okay. Give me a question. All right. Does this function the same as the other function? What's going on? This one is in standard form. This one is in factored form, right? So what can you tell when something is in factored form? You can tell the x-intercepts. So we don't know the x-intercepts until we get it in factored form. So on this problem here, you've got a factor. And this one here, because they're not, in factored form. Now what can you tell? You can tell the degree. The degree of this is 3, the degree of this is 4. Leading coefficient here, positive. Leading coefficient here, -1. Okay? Anybody help me factor this thing here a little bit? Right, so we're going to factor a GCF. So there's a 2x squared we can undistribute here, okay? So 2x squared times what's left if you divide that out? X plus 2, right? Okay? So is there any place that this can be 0? Is there any place that 2, the number 2, can be 0? Is there any place where x squared could be 0? 0. Any place that x plus 2 could equal 0? -2. So really what I'm doing is I'm setting each of these equal to 0 and find out what makes them equal to 0. So 0 and -2. Multiplicity, right? Because that's squared. Don't forget the x squared. And then this one be a 1. So 2 plus 1 is 3. It does work out that the multiplicity or the degree is 3, right? Now, one thing you can tell when it's in standard form is you can tell the y-intercept. The y-intercept is the constant at the end. So what do you think the y-intercept is here? Yeah, there's no constant at the end. The y-intercept is 0. So this point is actually a y-intercept and an x-intercept. Okay, so let's put our x-intercepts on there. So we got only 2 of them. We got an x-intercept at 0 and -2. I'm going to put tangent at 0, and I'm going to put it that it crosses at -2. This point is an x-intercept and a y-intercept. Okay, doubles up. So, positive, odd. What's going on the left? An arrow going down or an arrow going up? Down. On the right? Up. So we should have it. Go here, cross here, come down and touch, and finish. Okay, you guys see if you can do the last one. You do need to factor out, I would factor out a -x squared. So I'll give you that for a hint when you're trying to